Hey there, Brendan. Back with you for Chapter 5. Archard is standing by to walk us through the real world of testing. We are moving away from those perfect, clean labs and looking at how to handle the messy reality of your actual production network. Grab your coffee, follow along with the slides, and let us learn how to build a proper safety buffer so your automation never turns into an expensive surprise. Let us get into it.
Chapter 5. Testing changes safely before they go live. If you can't break it safely in testing, you'll break it dangerously in production. When testing means nothing. At 2:15 p.m. on a Wednesday, a telecommunications company deployed new network automation to update security settings across their infrastructure. The automation had been tested in their laboratory. It worked perfectly on the 10 devices in the lab. The engineer confidently deployed it to production. Within 20 minutes, 847 branch offices lost internet connectivity. Customer service centers couldn't process orders. Retail locations couldn't accept credit card payments. The company lost approximately $3 million in revenue during the 8-hour recovery period. Regulatory fines added another $500,000. The problem wasn't that the automation failed. The automation worked exactly as programmed. The problem was that the laboratory contained 10 identical devices running current software, whilst production contained 847 devices of 12 different models running 7 different software versions. The automation worked on current software. It catastrophically failed on older software versions that the laboratory never tested. This chapter explains how to build a safety system that actually protects your production network, not one that merely gives you false confidence before disasters occur. Why most testing fails to protect you. Walk into most organizations and ask about their testing approach. They'll show you a shelf of spare equipment in the corner of the data center. They call this the lab. They might even have a small virtual environment running on a server. The problem with these labs is that they are perfect worlds. They are clean, simple, and consistent. Your production network is none of those things. Production is a messy world of legacy equipment, weird configurations made during 3 a.m. emergencies, and software versions that should have been upgraded 5 years ago. Testing in a perfect lab proves only that your automation works in a perfect lab. It tells you nothing about whether it will survive the reality of your production network. The 3 environments. Building the safety buffer. To protect your business, your architecture must separate the journey of a change into 3 distinct rooms or environments. 1. The sandbox, where you experiment. This is a purely virtual environment where engineers can try new ideas without any risk. It doesn't need to look like the real network. It's like a sketchpad for an architect. If you break the sandbox, nobody cares. You just delete it and start again. 2. The staging area, the digital twin. This is the most important part of your architecture. The staging area must be a digital twin of your real network. It must have the same equipment models, the same software versions, and the same complex configurations as production. If production has a 10-year-old switch running buggy software, your staging area must have that same 10-year-old switch. Your automation must prove it can handle the messy reality here before it is allowed anywhere near your customer's data. The 3rd environment is production, the no-go zone. This is the live business network. In a professional architecture, no human ever makes a change directly in production. Instead, you promote the code. Once the automation has been proven in the staging area, the exact same code is moved into production by the system, not by a person. The golden rule of testing: identical code. The biggest mistake teams make is having different versions of their automation for different environments. They have a test script and a production script. This is a recipe for disaster. If you change the code between testing and production, you haven't actually tested the code you are running. A safe architecture ensures that the exact same instructions are used in every environment. The only thing that changes is the target, the network the instructions are pointed at. Takeaway: a lab is for learning. A staging area is for proving. You need both to survive. The strategy of safe promotion. How do you move code safely from the sandbox to production? We use a process called a pipeline. Think of a pipeline like an automated assembly line in a car factory. At each stage, the car is inspected. If a bolt is loose, the assembly line stops immediately. The car is not allowed to move to the next station until it is perfect. Your network automation should work the same way. Stage 1, the code is written in the sandbox. Stage 2, an automated linter checks for typos and security risks. Stage 3, the code is deployed to the staging area. Stage 4, automated tests verify that the network is still working correctly. Stage 5, only after all previous stages pass is the code promoted to production. What you need to believe. If you can't break it safely in testing, you'll break it dangerously in production. Testing in an environment that doesn't mirror production is merely theater. It provides false confidence that masks real risk. The staging environment is your most valuable security control. It is the only place where you can prove that automation handles the messy reality of legacy equipment and varied software versions. Code must be immutable across environments. Never use separate code for different environments. Code duplication guarantees eventual inconsistency and multiplies maintenance work. Test for failure, not just success. If automation cannot fail safely and roll back reliably, it cannot be trusted to succeed in production. Deliberate failure testing exposes problems before production encounters them unexpectedly. Enforce separation of responsibilities technically, not just procedurally. Policy documents that can be bypassed don't satisfy regulatory requirements or provide real protection. Technical controls that prevent bypass do both. If you implement one thing from this chapter, make code promotion automatic and ensure the code is identical across all environments. This single decision prevents the majority of testing-related failures. When tests succeed with code version 2.4.1, production deploys exactly that same version 2.4.1. Not a similar version, not a manually updated version, but the identical tested code. This gives you genuine confidence that production will behave like testing predicted. The effort invested in proper environment separation and testing seems excessive when you're building your first few automation scripts. The value becomes obvious when you have dozens of automation jobs, multiple engineers working simultaneously, and auditors requesting evidence of your last 100 changes. By then, retrofitting proper separation is expensive and disruptive. Building it correctly from the start is cheaper in the long run.
And that is why the staging area is your absolute best insurance policy. True reliability comes from testing against the messy reality of your network. Not just a perfect lab. If you have ever had a change work in the lab but fail in production, tell me about it in the comments. I would love to hear what happened. Up next in Chapter 6, we are talking security, specifically how to manage the keys to the kingdom. I will see you there.